Hey, College Math, here is section A.3. Here's the last part of A that we'll do for this year. Okay, so after A, we're going to move on to chapter 1. We're going to do percent change and scientific notation. Our objectives are to calculate percentages and percent change and then review converting to and from scientific notation. Okay, so let's go ahead and start with calculating percentages and percent change. Okay, that first part, calculating percentages, we're going to take a look at kind of some realistic scenarios that maybe you'll find yourself when you're out shopping or buying things, right? In our first example, we recently ordered Domino's pizza, and your total comes out to $26.37. If you want to give the delivery driver a 20% tip, how much will you owe overall, right? Thinking about it, this is a bad example because if you order on Domino's website, they calculate the tip for you, but you won't always be able to calculate the tip, right? And if you want to leave exactly a percentage or have a better idea of what that percentage might be, you'll probably want to be able to calculate it, somewhat quickly or on your calculator, right? So here, if we want to calculate a 20% tip and figure out how much we're going to owe overall, we're going to first want to take this 20% of 26.37. So let's start there. If you remember from 8.2, how do we calculate a percentage of a number? We start by taking our percent and converting it to a decimal. So 20% becomes 0.2. Technically 0.20, but that 0 after the 2, since there's nothing after the 0, doesn't make a huge difference. I can leave it as 0.20 or 0.2, okay? And to take the percentage, I multiply this by my value, so times 26.37. Okay, so if we calculate that, we take 0.2 and multiply it into 26.37, we're going to get a total of 5.27. We'll round it to 27, okay? And so that's not our total. That's how much our tip is. That's how much we're going to leave this delivery driver as a tip. So since we're going to owe more, we'll need to take this value and add it back in to 26.37. So the total is going to be 26.37 plus the 5.27, right? Okay, covering my dollar signs. So I'm going to add 5.27 back into the 26.37. And we're going to get that our total, the thing that's going to get us, that we're going to get charged, is $31.64. Okay. And so it's important that you remember that last step, right? It doesn't make sense for our new total to be $5.27 when we're going to owe more because we want to give them a tip. Okay. And so we'll need to make sure we add that percentage back in. It's a little bit different from, for example, if you're trying to figure out a sale, right? If you have a shirt that costs, let's say $15.99, and it's, let's say, 40% off, we do this one a little bit differently, right? So if it's 40% off of $15.99, we're still going to start by finding the 40% of $15.99. Okay, and if we calculate that really quick, 0.4 times $15.99, that gives us, oops, I misclicked, times $15.99. We're going to get that 40% is $6, and that rounds up to 40 cents. Okay, since it's 40% off, I'm taking this away from the $15.99. Okay, whenever I have a sale going on, I'm going to owe less than I normally would. So it's all about using those kind of context clues and kind of, being logical about it, right? If you're going to tip someone, you're going to owe more than what you normally do. So our total better be bigger than what we started with. When we have a sale, our total is going to be less because we're going to pay less than what we normally would owe. So our answer here, $15.99 minus $6.40, comes out to $9.59. Okay, and that makes sense because when it's a sale, it should be less than what we owe. Okay, always good to think about, kind of remember the logic in some of these situations, right? Don't get bogged down too much by the math. Okay, so now let's talk about a different type of thing we could do with percentages called percent change. Okay, so percent change is kind of when we think about, okay, if a quantity changed, I don't really necessarily care about the whole numbers that it changed by. I care about the percentage. So how much of the original percent did my amount either increase by or decrease by? So if I want to calculate percent change in general, okay, so percent change, that's going to be equal to the new amount minus the old amount divided by the old amount, okay? And so percent change, when we think about change, that means we're going to have an old value and we're going to have a new value, because when we change, we start from one place and end up in another. And to find that percent change, we're going to take the new minus the old and divide it by the old, and then convert to percentage, right? Because whatever we get from this is going to be a decimal. And so we'll want to convert it to a percentage by moving that decimal place over. Okay, so let's try that here in this next example. Okay, example 2, if you decrease your weekly phone screen time from 300 minutes to 211 minutes, by what percent does your screen time decrease? Oh, and one last thing I forgot up here. We're going to actually put these bars on this. Okay, these are absolute value bars, if you remember from algebra 2. So absolute value bars. And hopefully you kind of remember what the absolute value does. If you don't, what absolute value does is it makes number positive. And actually I should put here, instead of number, I should put result. Makes result positive. So from here, when I do this calculation, if I get a negative number, I'm gonna just immediately make it positive. And if I get a positive, I'm gonna keep it positive. I'm not gonna change it to negative. I just want the answer to be positive, okay? Because when we think about percent change, the decrease, or in the problem where it tells us increase or decrease, already takes care of that. We don't wanna add in the extra negative, okay? So now let's go ahead and try this right here. If I wanna calculate the percent change, okay? So the change is going to be equal to my new value. So my new screen time was 211 minutes minus my old screen time, which is 300 minutes, divided by my old screen time, which is 300 minutes. Okay, so let's go ahead and calculate that. Okay, we have 211 minus 300. That's going to give us, and I forgot my absolute value bars, not bad. That's going to give us negative 89 divided by 300. Okay, keep my absolute value bars. And so when we divide negative 89 by 300, we're going to get absolute value of negative 0.296, and then I'll round that up to 7. I'm still in the middle of my work. I don't want to round until the very end, okay? And so here, these absolute value bars are going to make this positive. So now I have a positive 0.2967, okay? And then from here, I'm going to convert to my percentage. So I move my decimal place over to the right 2 times, and I get 29.67%. Okay, so that's my change. Okay, I decreased by 29.67%. That means that the difference, this 89, is 29.67% of this 300. Okay, that's how much I decreased my time by. Now, when we increase, we're not going to have to stress too much about the absolute value bars because it'll be positive, and so we'll just, at the end of our problem, we can just drop them because it'll already be positive. Okay. So you only have 2 scenarios: either you increase or you decrease. If you're increasing, this is going to be positive. If you're decreasing, like we did here, it's going to be negative. Okay. Now, for the last concept of this video, let's kind of talk scientific notation. Might have been a while since you learned scientific notation, or maybe you reviewed it or talked about it in like a recent science class, either your chemistry or physics class. But scientific notation is just a way for us to express really big or really small numbers. And we can actually express any number in scientific notation, but it's most useful when we have huge or very tiny numbers, okay? So scientific notation, the way you're going to see it is you're going to see some number, let's just call it number C, times 10 to the power of some n. Okay, so the rules of scientific notation is that C has to be between 1 and, actually, no, yeah, that's right, 1 and 10. Okay, not including 10. I don't want it to be 10, and I'm okay with it being 1. Okay, so it's including the 1, not including the 10. Mathematically, we would write it as 1 would be less than or equal to C, less than 10. Okay, that means that I can be 1, but not 10. And then n is just some integer. Okay, so either a positive or a negative whole number for the integer. Okay, so let's go ahead and see how we can convert to and from scientific notation. Starting with here, we're gonna take these numbers that are in standard notation, so that what we're normally used to seeing, and we're gonna convert them to scientific notation. Let's start with A, 47 million, okay? Sometimes you're gonna see these numbers with commas and sometimes without. If it helps you to kind of be able to work with the number, add in the commas if you need to, okay? So we have 47 million. We're gonna wanna convert this to scientific notation. So if we're going to scientific notation, we gotta find our decimal, okay? That's the first step, is to find our decimal. Here we don't see one, so we're gonna put it where it normally would be, here at the end of the ones place, okay? Whenever you have a whole number, the decimal is after the ones place. Okay, and then I gotta move it so that I get this number down to somewhere between 1 and 10. Okay, so I gotta take this decimal and move it. I don't wanna move it to the right because that's gonna make the number bigger, okay? I wanna move it so that it's between 1 and 10. So that means I gotta move it between this 4 and the 7, because then I'll get 4.7. Okay, so move it over once, twice, 3 times, 4, 5, 6, 7. Okay, you wanna count how many times you move it. So now I have 4.7 times 10, and then the exponent is gonna be how many times I move my decimal. We counted 7 spots, so it's gonna be 10 to the 7th power, okay? So first step was to find our decimal. If we don't have the decimal shown, if it's a whole number, put it where it normally would be, which is after the ones, okay? Then we're gonna move our decimal enough places so we get this number down to between 1 and 10. Okay, in this case, I got 4.7. And then it's gonna be times 10 to the number of places that I moved in, okay? A big number means a positive exponent on our 10. So if you want to, we can write that down. So n positive, that means we have a big number. Okay, so by big number, I mean something bigger than 1, okay? And by n, if our exponent is negative, that means we have a really small number, okay? Something less than 1, between 1 and 0, okay? Between 1 and 0. Okay, so now let's look at B. This is an example of a number between 1 and 0. Okay, this is not less than 0 because it's not negative, and it's definitely not bigger than 1, okay? So my goal, again, remember, I want to find my decimal, so that's right here. I want to get this number to be between 1 and 10. Okay, so if I'm looking, it looks like I'm going to want to put it here. Okay, so I'm going to move it once, twice, 3 times, 4 times, okay? And you're probably wondering, well, how do I know that I can't keep moving it? Well, if I move it one more spot over, now I have 10.034, and I don't want it to be bigger than 10. I want it to be smaller than 10. So I can't move it over one more spot. Okay, so it's going to stay there. So then my number now is going to be 1.0034 times 10. How many spots did I move it? 1, 2, 3, 4. And since this was a small number, because I moved it over to the right, I need to have this exponent be negative because this is a tiny number. This is a decimal value. Okay, a number smaller than 1, bigger than 0. Because this was a big number, my exponent needs to be positive. This is a tiny number, so I need to be having a negative exponent, okay? Now let's go ahead and finish up by going backwards. Let's go ahead and take numbers that are in scientific notation and write them in standard notation, okay? So I have 2.379 times 10 to the power of 2 for part A, okay? I see a positive exponent, so that means I need a big number, okay? Well, how do I get a big number? Do I move my decimal to the left or to the right? That would be to the right, okay? If I move this to the left, that's gonna make the number smaller. So that means when I see a positive exponent and I'm going to standard notation, I should take my decimal and move it over to the right that many times, okay? So I'm gonna take my decimal, move it once, twice. So I get 237.9 is my answer, okay? Last one over here, I have a negative exponent. I have 4.675 times 10 to the negative 8. So that means that this is supposed to be a tiny number, which means that the decimal is going to go to the left, okay? So I'm going to rewrite it down here to give myself some room. 4.675 times 10 to the negative 8. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, and then just fill all these little valleys with zeros. Okay, so I have 1, 2, 3, 4, 5, 6, 7 zeros. My new number is 0.1, 2, 3, 4, 5, 6, 7, 4, 6, 7, 5. Okay, and if you want to be able to check your work with some of these, like this one, you might be like, oh, I don't know if I did that right. Move the decimal back, okay? You should be able to get 4.675 by moving the decimal back 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Yes, I did that correctly because when I move my decimal back 8 times, I get what I started with in my scientific notation. Okay? Hopefully that sounds good, you guys. Like I mentioned in the previous video, again, if you're working through these notes and you come across one of these that you're like, I have no idea what he just did there, make sure you star it on your notes, okay? Or write yourself a little note in your written notes to ask this question in class, okay? We can definitely take time during class to answer questions from the notes, okay? All right, have a good rest of your night. I'll see you in the next one, okay?